Hello, algebra students. It's Mr. Pouts here with video for section 2-4. Now, we already had the first part of 2-4, so this is going to be section 2-4 part B. And we're going to deal with the second goal, which is to identify equations that are identities or have no solution. So we're still dealing with those multi-step equations or equations with variables on both sides. But now we're going to find some that have no solution or are called identities. We'll talk about what that means in just a second. So here is what I want you to look at. Solve the following equation. All right, so remember, if we have for just a regular two-step equation or multi-step equation with variables on both sides, one of the requirements is to first, well, let's look at the rules here. So we said, I know it seems like a lot. The fifth step is always just to check. But first, simplify both sides if you can distribute or combine any like terms. Here's our two sides. Left side, nothing you can combine, there's no distributing. Right side, there's nothing you can combine because they're different and there's nothing to distribute. So that's step one. Step two, use inverse operations to move the variable terms to the same side. So we're going to usually subtract, but we want to get, so I'm going to subtract this x, this 1x, from this side, so we can get it off of this side, and we just have the variables on one side. So when we do that, that cancels out. We'll subtract x from over here, and you'll notice x minus x, that also cancels out. So all you're left with then is 1 equals 2. And that makes me think, what? Well, this is one of the situations we're going to deal with today. 1 definitely doesn't equal 2. So if you get an equation like that, that's, hopefully you notice that that's actually something going to be called a no solution. Okay? There is no solution if they're not equal. So that is one of our terms here for right now. And so I'm going to show that first. No solution is an equation that has no possible solution. So if you end up getting something that is like not true, two things that are set equal that are not true, like we just had, that is a situation where your answer would simply be no solution. Whoops, no solution. Okay. Now the one that we've been dealing with most often is when there's one solution. So an equation that has only one possible solution. That's what we've been dealing with so far, and we've been coming up with just an answer for x. So when we have like x equals 4, that's what we solve for, and it works out, and then that would be one solution. The other new situation is called an identity. And I'm going to put it in parentheses here. That's also known as infinite solutions. That means you could plug in any value for the variable, and it'll make the equation true. So an equation that is true for every possible value of the variable. And I'll show you what'll happen when you have an identity situation as well. All right. So we'll do an example of each, and I'll show you what it looks like. And these are each of these three things are probably really important for you to take notes on. So let's start with this first one with the one solution. This is what we're familiar with. All right, so we have, let's just divide up the two sides right away. And I'm going to simplify the left side. Looks like with this parentheses, with addition inside, and a number multiplied by that parentheses, you're going to distribute. So when you distribute, you do 4 times 2y. And then you keep your addition, and then you do the 4 times the 1. And you end up getting then 8y plus 4. And we're going to carry that equal sign on down. Let's see about the right side. 2 times the y. Some more distributing here. And keep your minus sign. 2 times 13. So we end up with 2y minus 2 times 13 is 26. Alright, so let's go back and review these steps. First, simplify both sides. We did that. We did our distributing. There's no like terms that we can combine. Step 2, use inverse operations to move the variable terms to one side. Alright, let's get rid of this 2y, because if I subtract 2y from this side, I'll do it to the other side, and it'll still be a positive one. If you subtract 8y from both sides, then you get a negative 6y over here. So let's try to deal with positives. So I'm going to subtract the 2y, and then I must do to the other side of the equation, the other side of that wall, and I'm going to do it by the y's over here to make it easier on myself. Now this is gone. That's what we were hoping for. So we're left with this minus 26 over here. 8y minus 2y is 6y plus 4. Now you notice it's a two-step equation. So we can first get the constant terms. So we want to move the constant terms or the number terms to the opposite side. And then do our either division or multiplication, which would be our inverse operation. So first do the subtraction. Get rid of the addition here, so we're going to subtract. Do that to the other side. Minus 4. Now, negative 26 minus 4. They're both negatives. So it's negative 26 degrees outside, and it's going down 4. You get to negative 30 degrees. That's a negative 30. And this would still have 6y over here. Our last step then is to divide by 6 to undo that multiplication. And you have to do it to the other side of that wall. So y is left here. Bring down the equal sign. Negative 30 divided by positive 6 would be a negative 5. So I got one solution. I could check it by pulling it back in for the y's on there and seeing if the two sides are still in balance. I'm not going to do that right now. But a one solution equation, following those steps, you'll find one solution. This one we have y equals negative 5. Let's try this one on the right here. So I'm going to make this wall again. And I'm going to start by doing those steps again. Simplify both sides and see by any distributing or combining like terms. The left side, there's nothing I can do. So I'm going to bring that down and keep that as 10x plus 12. And carry down the equal sign as well. This side, though, I see that parentheses again with a number in front of it. So I am going to distribute. So that's the 2 times the 5x. Keep the plus sign and do the 2 times the 6. That's distributing the 2. So you end up with 10x plus 12. Oh, I apologize. I made a mistake here. I accidentally wrote plus 12 instead of plus 11 on the left side. That's an 11 up there. I just copied it down wrong there. Oops. So I have 10x plus 11 equals 10x plus 12. So after I do that simplifying, I'm going to use an inverse operation to get rid of the variable term from one side. So the whole term, remember, not just like the 10, I want to get rid of this whole 10x so there's no variables on this side. So I'm going to subtract the 10x from this side so that it's gone there. Now I'm going to subtract 10x from this side, and 10x minus 10x, that's gone too. So we're just left with 11 equals 12. Now, last time I checked, 11 does not equal 12. So that means that's not true. We have no solution here because we can't go any farther. There's no more variables in there to try to solve for since it went away. And 11 does not equal 12. Okay, so that's in a situation where you have no solution. If the variables are gone and then you have something that's not equal to something else. Now this last one would be an example of the identity situation. So I'm going to make this wall again. I'm going to try to simplify this and follow the steps. So the first step is to check for any combining like terms on each side or distributive property. The right side, there's nothing I can do here. That's just negative 6 plus 12b. Can't be combined because one has a b and one doesn't. Left side, though, I see that I can do this, the distributive property with the 3. So I end up with 3 times 4b. Bring down the minus and have 3 times 2. And then that would be 12b minus 6. Carrying down the equal sign and everything else that's on the right side. All right, next step. We are to get rid of the variable term on one side. So I'm going to simply take this one on the right. They're both the same. So I'm going to take this one on the right and get rid of this 12b. So subtract 12b. So get rid of the whole chunk there. Not just the b, not just 12. The whole 12b. So we have to do this over here as well. And 12b minus 12b, that is gone as well. But what's left is still this minus 6. And over here is also a minus 6 or a negative 6. Those are true. Now, there's no variable terms left, but negative 6 equals negative 6. So that's true. So the answer would be it's an identity. Meaning that this is where you can have infinite solutions. So any value that you plug in for b on this one, any value that you would plug in for b would work for this one. You can plug in 6 for b. You can plug in, as long as you plug in the 6 in for both b's. If you plug in 1 for both b's, it'll work. Anything you plug in for both of the b's, it will work out. So you have an identity situation. So just to recap, the ones we've been working with for one solution, you'll get an answer. You'll solve it, you'll get an answer. It'll work out that way. No solutions, that's one solution. No solution equations, you end up getting, the variables will cancel out when you subtract from one side and then from the other side. And then you'll end up with getting something that's not equal to each other. This right here, that's not true. Meaning you have no solution here. This last situation, when you get rid of the variable from one side and it also cancels out the variable on the term on the other side, and you end up with two numbers that are equal to each other, meaning that the equation is true, that is an identity situation, meaning there's infinite solutions. Okay? Sometimes you'll have some no solutions or some identity situations. So you need to know the difference. And I want you to practice that with this one last example. I want you to solve the equation using the correct steps that we've been working on and tell if it has one solution, no solution, or is an identity. So go ahead, pause that, and go ahead and do that. Okay, I'm going to go through it with you. I'm not going to tell you if it's a one solution, no solution, or identity, but I'm going to go through the steps that I would take. Making my wall again. My wall of my equal sign. Left side of the equation, nothing can be simplified. 2x plus 7, those are not like terms. There's no parentheses. Right side, I see parentheses, so I am going to do distributing. So I have negative 1. I'm going to carry this down, by the way. 2x plus 7. I'm going to carry that down right away. But I have negative 1 times the 3, keeping my minus sign, and then I also have negative 1 times the 2x. Now, don't forget here, when you have, right here, when you have minus and negative, that becomes plus, or two pluses. And then I have negative 1 times 3 is negative 3, plus 1 times 2 would be 2x. All right, our next step would be to use inverse operations to move the variable terms to the same side. So let's get rid of the one from this side. So plus 2x, I have to subtract 2x to get rid of that whole term. So that is gone. And I must do it to the left side of the wall, or left side of the equation. So, well, that cancels that out too. So it's 0 plus 7 equals negative 3. So 7 equals negative 3. We're ending it up with this. I want you to tell me, is there one solution, no solution, or an identity situation here? Please take a look back at your notes from these examples. They might help you. Until next time, have a good one.